in the build-up to Future Manufacturing Technologies Conference and Expo 2019. My name is Philip Bell. I'm from Go-Konnect, the organisers of the event, and I am happy to be joined today by Vladimir Navrotsky. Vladimir is Chief Innovation Officer at Siemens Industrial Turbomachinery in Sweden, and he will be speaking on the 3D printing live stage at FMTX in Malmö this May. So firstly, welcome, Vladimir. It's great to speak to you today.
Thank you very much. It's a pleasure to share what we are doing in the area of additive manufacturing with you.
Fantastic, fantastic. We'll dive straight into the questions. So first off, you've been using additive manufacturing for a number of years now. What do you feel is the biggest benefit that you've gained from using additive in comparison to traditional manufacturing techniques?
Yeah, you're right. We're already using this technology for some time, almost 10 years already. And then looking on the added value or gain benefits from this technology compared to the conventional, I would like to say, first of all, it helps us to improve the performance of our products, for example, gas turbines. So we increase the efficiency of the gas turbines, we increase the lifetime of the components, different components. So we were capable to reduce the emissions directly through the better combustion and then from the higher efficiency. So this was also a drastic time reduction for the design and validation. So there, I already in the previous your events, I already share our experience in the blade design where we did demonstrate that now we can shrink the time of design and validation from 2 years to 2 months. Yeah? So and then additional issue was, which is really amazing. So with this technology, actually, we have no limitation for design. So usually we are saying that what can be dream can be print. This is like a message our designers in the Siemens currently have. So looking on some numbers, some facts, so it would be good not only to talk about the qualitative issue, but the quantitative issue. So, and this is a number which we draw from our experience. So up to 65% less resources during the production. Yeah? So it's in terms of the materials, in terms of the headcounts, 60%, up to 60% fast and quicker repairs. So then about 50% quicker the manufacturing and then validate as I would say validation. Yeah? So 30% emission reduction only through the manufacturing. So in addition to what I said, that we have an emission reduction from our products, so that we are burning less gas, and this is why we produce less emissions. So we are burning this in a more effective way. So this is why we produce less emissions. So the process, the manufacturing process itself, in average, can help us to reduce the negative impact of the emissions up to the 30%. So another very important topic is spare parts on demand. So now we are really reconsidering our supply chain management and coming to the digital spare parts. And also there's a very powerful tool in the obsolescence management.
Okay, fantastic. Well, it seems like it's adding benefits across the whole of the manufacturing process. From an internal perspective, what have you had to kind of change in order to support additive across the organization?
Yeah, this is a very important topic, and I really appreciate very much that you are asking, because from my point of view, this was one of the critical points just from the beginning.
Yeah.
First, what it was necessary to do, it was necessary to change our mindset, and mindset across the whole organization, everywhere, including even designers. Yeah? So, and the next step was, first of all, it was a change of mindset. It took a lot of time, it took a lot of efforts. It's not so easy, let's say, to have this kind of a transformation in our mind. Yeah.
Yeah,
we were capable to do this. Unfortunately, it took a little bit long time. So the second, what was important to do also was to establish a dedicated additive manufacturing team to cover the whole chain of the additive manufacturing. Yeah. So and this was our, let's say, understanding from the beginning. If you would like to be successful, so we need to take care about the whole chain of the additive manufacturing, starting with the powder and finishing with the collection of the feedback from the field, from the operational experience.
Yeah.
And this is what we did. Another very important topic was to accept and to tolerate that we can fail. So the failure tolerance was accepted. At the beginning, people afraid when we said, guys, don't worry, just do the mistake. It's accepted. We even appreciate if you will do the mistake. It was received a little bit carefully from the beginning. But now everyone understood that this is a way how we can, let's say, do it. So if we would like to be successful, we need to act. When you are acting, of course, you are not, let's say, protected from the mistakes.
Okay.
So, and another very important topic, I believe, for the success was that we did start from another side. Usually people start with the additive manufacturing from the design, prototyping. We did start 10 years ago from the repairs.
Yeah.
So, and this was a really important point because it was less risk. So this risk was, let's say, control. And this was really one of the success factors of our quick industrialization of the additive manufacturing. So, and another success factor and what need to be changed, you need to be, let's say, skilled, and you need to understand what components are applicable for this technology.
Of course.
Because not all technologies, we have different technologies in the additive manufacturing, but not all technology, there is no one technology which could be applicable for any application. So, and this is important to recognize. Yeah.
Perfect. So it's very, very important to have the right skills and understanding of which technologies you can apply to which.
Yes, correct. Absolutely.
Processes. Okay, perfect. And moving on, one of the hot topics at the moment is how to really utilize additive for serial production rather than, just looking at R&D or small batch manufacturing. Is this something that you've been working on as well?
Yeah, absolutely. And this was done from the beginning. So we said that our major goal is to go with the serial production. And of course, in order to, let's say, to have a business case flying, so we focus on the high volume, high complexity, and high value components, which are the parts of the gas turbine components. So, and this was our focus from the beginning. So we did use the additive manufacturing as a tool, which allowed us to make our product more competitive, create more value to the customer. And then, of course, in order to, let's say, to justify the business case, we need to have a volume and high value and high complexity components. I also would like to say that we're already in the serial production since 2013. When we put, as already said, we start with the repairs, and we put the repairs of our burner in the serial production in 2013, and that was the first time we also put one of the components into the combustor for the serial production, because this was the only technology which allowed us to realize the required design into the metal. Okay. So, and saying about our goals, so we are planning to print about 200,000 components starting from 2023 in the 5 years. Yeah?
Wow.
And what is important as well, so that we can demonstrate the available experience. So the first components which was put into the serial production in 2013, today accumulated more than 36,000 hours of very successful operation in the very hot and stressful environment. Okay, so sounds like the serial production is really, really there, and it's also offering great value at the end as well. In the time that you've been using additive, how has the technology and availability of materials developed? Yeah, and then when I said that we from the beginning said that in order to be successful, we understood we need to address the whole chain, including materials and powder. And from my point of view, this is the most challenging, let's say, part of the overall additive manufacturing value chain. Okay. So because it's a most time consuming and then, let's say, cost and then funding consuming process. And especially for our application, when we are talking about high temperature application for the gas turbine components, where you have a huge centrifugal forces, and then you have a high temperature very close to the metal melting temperature. So to build the whole spectrum of the material properties, like a creep, like a TMF, and like a LCF, required a lot of time and of course investment. So, and we did start from the beginning with the nickel-based materials. This was the first one because I said that we start with the repairs. And after it took us some time in order to understand that we cannot simply, let's say, apply this for the standard chemical composition of the different standard materials. We start with the Hastello-X, and after quite some time we found in order to be successful, in order to make this as a metal, to print this as a metal and not as a glass, we need to change the chemical composition. So, and today we qualified quite a few materials.
Okay.
So, in the area of the nickel-based materials, stainless steel, titanium, and aluminum. Yeah.
Okay, so things have been developing quite nicely then over the course.
Yes, but as I already said, it's time-consuming and expensive, to be honest. Yeah.
Challenge and expensive, of course. You touched on it earlier in terms of some plans for aims for 2023, but can you just give us a bit more detail about what's next for you guys when it comes to the adoption and rolling out of AM across the business?
Yeah. So as already said, we already have quite a few components in the serial production. And our next step is scale up the production and then really realize our plan to print 200,000 components a year. So in order to be capable to do this, we are looking for the full industrialization and automation of our AM value chain, including all processes, material, and then design and manufacturing. So we are looking for the industrialization of other technologies. So currently the major focus we have, it's mainly SLM technology. But as we already said, SLM technology is applicable for the certain parts, but we have other application. This is why we are looking currently and do the progress in the implementation of the other technologies like laser metal deposition and the EBM technology. And also we found that the binder jetting could be also very effective in the certain components in the certain application. So this is what we are focusing as well. So it's not only SLM. We need to expand the type of the additive manufacturing for the different application. So we are looking for the other components and not only gas turbines, but application for other Siemens components. In the past, I also mentioned that by getting and accumulated knowledge we currently have in the overall supply value added of the additive manufacturing, we have a knowledge, we have a sufficient knowledge experience, and this is why we found that we can offer the service providing in the additive manufacturing in all respect, training, in respect of the supporting any customer in terms of the design for additive, help them to work with the materials, with the technical issues, provide some printing for them if they need, and maybe even to help them to support the AM workshops. So, as I already said, it's we currently, localize in two areas. We have two footprints, one in Finspång, another in the UK, in the Worcester. So, but we are looking also for the regionalization to be more close to our customer.
Okay. Good stuff. Well, it sounds like exciting times and that you've got a lot to keep you busy over the coming years. Yes,
this is correct. And then we are saying that now it's a time to do it. Do it in the systematic and then strategic way.
Good. Well, it sounds like it's going to be a very, very interesting presentation that you'll be giving on the 3D printing live stage at FMTX, and very much looking forward to hearing it in person. So just wanted to say a very big thank you for your time today, Vladimir. It's very much appreciated, and we look forward to seeing you at the event in May.
Yeah, thank you very much as well for the opportunity to share our current experience with the people who is going to join this activity, and I'm looking forward to share even more information in the coming event.